I randomly picked Osaka, Japan, for this example. So within the geography and demographics group, we have GDP per capita, it's 39.7 K, and population, 12.8 million. And because the hub just serves not just itself, but nearby cities, what's the population of nearby cities within a certain radius? But you probably will see an immediate problem. How do you compare effectively across different units? How do you compare GDP per capita in one city with population in another? To do that, we have to normalize it. And we're normalizing things on a score, everything of 0 to 100. How are we doing that? The smallest city in our data set is a little hamlet that some carrier had to pop in, that population of 500. The largest city is Shanghai, or largest metropolitan area, Shanghai, 32.2 million. Osaka sits at 39.8% in between the min and max ranges there. So it gets a normalized score for this one little category of 39.8. Overall, in this group, it's a simple average of 27.6. And we do the same thing for cloud infrastructure. How many local zones, on-ramps, regions, planned regions. It gets a score of 28.3. And then we can go and do that through dozens of different data sets. And at the end, if you average them all up, a very simple average is 39.6. Now alone, that's not terribly meaningful. What's that mean? I'm 39.6, well, congratulations. But it is meaningful when you start comparing one metro to another. A 39.6 rating or score is good for 19th in the world. That's where Osaka lands. So you might be thinking one of two things right now. One is, hey, I didn't realize there was going to be any math involved in this. I'm sorry about that, but we're through with the boring part. We're on to the cool infographics and the results of the model. On the other hand, you might be thinking, man, I want more of this. I want not just Osaka, but all 8,200 in the world and every single data set. So I thought you might. So I took a screenshot of 600,000. So feel free to take a photo now and study it later if you want to.